DraftScience physics video. So sort of just a overview, conversational kind of thing, just to talk about the idea of challenging the conventional perceptions of our reality as the smartest scientists in the world perceive it. But this has always been a problem, this intelligence thing. You know, they have this idea of IQ or quotients of capacity, and a lot of that has to do with just the capacity, just an idea of how much you can store, how emotionally distracted you might be. You know, so many factors in terms of how efficient, let's say, somebody's brain is at certain activities. But the key to reasoning and logic is experience with, let's say, facts and perception, and understanding that we often we could find times in our lives when we allowed ourselves to be deluded because we wanted something to be true, because we had to become very attached to it. It was our hero as a fact, and we didn't want to find out that our fact was a piece of crap. I could say that in a way I had that kind of conflict with my perception of nature, because part of me had a great affinity with nature, and I was kind of a Dr. Dolittle. You know, people would call me just because I could handle animals very well, and blah 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 blah. I just had a knack with being whatever functional in that world of beasties, and sort of a snake charmer kind of a thing, or whatever, a reptile whisperer. Yeah. But anyway, and it bothered me to when I had to start recognizing that nature wasn't the good friend I thought it was, in a sense. Not that I thought it was a good friend. I mean, I knew from a very young age that life was brutal, but I didn't sort of blame nature for it. I sort of blamed the human convention. But anyway, that's that's a whole separate subject, right? Yeah. So, but it's the relationship here is just that here's this conflict in something that should be a pretty rigid science, run by people who are very meticulous about getting it right, putting things in perspective, proper proportionality, all of that kind of thing. And the real problem with this quantum mechanics thing, as described, is it's turned into a philosophy, and the rules of proportionality and fair description and accuracy just don't matter anymore, because it's a religion in a sense that it's a devotion. And people's devotion is completely bigoting and biasing their ability to recognize that maybe the evidence isn't so good. Maybe the heroes of the New Age weren't so heroic. And they just don't want to deal with what I think the evidence indicates, which is they're contriving a reality, not discovering reality. And, you know, these descriptions that are now established as unchallengeable truths of our existence are very challengeable, and they are the evidence is still weakly composed for the individual subjects, where I might argue that the broader perspective indicates that many of these wish theories just don't have any credibility. They can't survive, because they do create paradoxes that you're not going to be able to fix with anything like anything other than a contrivance, a fake, a bit of bullshit. So anyway, Hothladay made a response video. This is the same old dodge. Frankly, you can't convince this idiot that something like sensations actually exist and have meaning, in the sense that they're events that happen in the universe and that they have a definite character, that torture is somehow worse than bliss. He doesn't accept that as a reality. So obviously convincing him about something is probably just a waste of time. I mean, he can't get something that he actually experiences. He actually conducts the experiment in his own brain, and he still can't understand the concept. So his dodge, his evasion is that all of this stuff online, all of these different elements of information, including lectures by well-paid professors at very expensive colleges, are not obliged to be accurate. They're doing some sort of expedient thing that's acceptable, and that lay people just don't get it, that when they're saying this stuff, they don't mean it to be serious, and they're just talking about some model that they don't think is the absolute truth, even though they claim it to be the absolute truth overtly and aggressively, and claim it to be the most perfect predicting math in the history of mankind, and all of this crap that they say that has to do with establishing it as a truth. And he's just going to pretend that none of that is said, that that's not the real context of the presentations, that they're all supposed to be just cartoons. It's just a complete evasion of the true description, which is science has allowed itself to become propagandist for a philosophy, and there's very little discipline being exercised by the participants in the discussion, because they're so elated and aggressively wondrous in their speculations about reality that they have, and so many of their fundamental theories are just speculation that they can't tell wild speculation from demonstrated truth, and they're blending the two of them all over the place. So anyway, just a complete dodge of what I have demonstrated, which is even simple experiments, very simple, incredibly simple experiments, can't be honestly described or accurately described, because the agenda is more important than the truth. And the elements that verify their theory will be exaggerated. The elements that make their theory seem implausible will be ignored. And that's what's taking place, and instead of just admitting it, it's this denial. Okay. Now, Puro's video was useless, in the sense that he doesn't even listen to the videos while he was responding to them. So not only does he not listen to them when he listens to them on his own time, but even when he's doing a response video, he doesn't even pay attention to the video, and he takes phone calls or does this or does that, and then pretends like he heard what the person said or he understood the point being made. And it was almost so laughable that it's like you could laugh at it. It's such a joke, in terms of a response. A curious thing was, I mentioned this the other, just because I noticed this thing. So see, I can't tell with this crappy camera because the image doesn't really work, but you can see that, I'm pretty sure. Pretty dramatic visual, in the sense that it has it has the clear impression of Newton's rings, and yet it's created by, when I thought about it, a completely different phenomenon. It almost has, well, it kind of does have absolutely nothing to do with Newton's rings, in the sense that it's not the same kind of, it's always going to be a consequence of electrons and reflection and refraction, but it's a completely different kind than anything traditional regarding Newton's rings. It's completely unquantum mechanical, in a sense, that it almost has nothing to do with the aperture. It just has to do with the tube and reflections. So it's more of it's not even a rainbow. I don't even know quite how to describe it, but it's all just reflection based. but it's very interesting when you start thinking about it. It's just reflections inside the tube wall, and you're only seeing a portion of the reflections because of the Brewster angle or whatever. The half of the image disappears, so you're not seeing half of it, you're only seeing half. The other half is reflecting again, and then you're seeing half of that image, and then that's reflecting again, and you're seeing half of that image. And it's really quite interesting. As far as I can tell, I mean, there might be something deeper going on, but it's basically just a bunch of reflections, and you're seeing the world this way, and then you see it that way, and then you see it this way. Each ring is reversed, which kind of demonstrates the fact that there's got to be this crossover thing happening. Anyway, but so there's a phenomenon, and it looks exactly the same, but it has nothing to do with it. And this is like with the stupid water waves and the comparison to light traveling through slits. The two things have only the slightest connection to each other, in the sense that there's some mechanical similarities about the experiment, but the causes are completely different. So you have a similar result, Newton's rings, in an on-off pattern, but the cause is completely different. You can sort of see that with water, in the sense that it's not really on-off. It's a very wavy, and then no waves, very wavy, no waves, very wavy. So it's like all the way on, all the way off at frequency, which isn't what light does at all. So, and then there's no comparison in something like the single slit. The single slit in water doesn't do anything like what a single slit does to light, or electrons, or buckyballs, or whatever. And these things are indications that, wait, slow down, caution. And none of that caution is reflected in any of the presentations. This is the decisive nail in the coffin. I could put video clips together, quite honestly. I can put video clips together of all these different scientists, highly respected scientists, or all of them, and I could find them saying, nail in the coffin. The guy at Yale, nail in the coffin. The guy at MIT, Lewin, nail in the coffin. And I can, Feynman, nail in the coffin. I can probably find a clip of almost every physicist saying it. Like, this is the experiment, and clearly it's not the experiment. There's a lot to play with, and it's just obvious. And it's more obvious the more like I said, I demonstrate it, and people just ignore it. But I mean, here I'm showing people that, look, they're doing math for this, and the pattern is much more complicated than this. So obviously they're not predicting the results. They're predicting a portion of the results. And they don't have and again, and then, so anyway, so in Piro's video he says, well, look, I can do this computer simulation and blah, blah. I don't care about a simulation. I don't need to see a simulation. What I need to do is see the formula you use to contrive the result. So again, you could give me the formula for single slit diffraction, and the only thing that's relevant in it is the little Huygens factor, which was is how you do the formula. It's not like, well, here's the formula, because you have to kind of know, oh, you're supposed to do this formula twice. I mean, formula twice in the sense that you're supposed to create two photons out of one photon to do the math, to get your sine theta. The formula doesn't say that, but you're basically, it's implicit in the formula that you have to have this sine theta, and the only way you get your sine theta is you have to create two photons. So it's built into the math is the presumption that there's two photons when there was only one photon, and you just Huygensed it. So the whole Huygens story isn't going to be in the formula. And if you do a simulation, your simulation is just going to be doing things that for which there's no model. There's no facts that indicate that's the truth. So yeah, I could model anything with a piece of math. I could statistically find out when my neighbor, the average time he goes out in his driveway, the average distance the car moves, all kinds of stuff. But am I am I giving you a formula describing why he does what he does, or am I just giving you a formula that vaguely tells the parameters? Like the formula will indicate that yes, he never spends 27 hours in a day, something like that. So math is not a model, and math isn't an explanation of why the relationships are meaningful, and that's important. So again, what I'm saying is, if you give me a real formula that does two-slit diffraction, what I'm saying is I will, that shows the real pattern, which is the two patterns combined. I will show in that formula the dark matter contrivances. I will show where, like in the Huygens example in the single slit, where you have used a contrivance based on the fact that you've observed what happens, and now you're just contriving a formula to match the results. You're not predicting the results, you're seeing the results and then backseat formalizing. Alright, and that's a different kind of mathematics, in my opinion. Alright, anyway. So then he made the argument that light from a laser spreads. Now, obviously not in these experiments. The amount of spread or divergence would be tiny. And I'm talking about the difference between dome light. The traditional experiment was done with an aperture that spread the light. The modern experiment isn't, and obviously that difference in the kind of light you're using in the experiment certainly is going to change what the mathematics. The fact that the math doesn't care indicates that the math is vague and imprecise, because it would certainly affect the intensity of the banding pattern depending on the different kind of light I would put into the experiment. So right there's a flaw in the mathematics, in my opinion. It's just made obvious by the fact that the two light sources are fundamentally different. The light source of 1925, let's say, and the light source of 2017 are very different. Alright, let's see. Shows single slit water. So again, he keeps ignoring the fundamental arguments, which are look at the single slit in water and recognize that there is no comparison. There's no similarity between water waves and light, and that this obsession with assuming wave mechanics when it's nothing, light is nothing like water molecules, and it's just cheating science to say that you have definitive evidence using this comparison. And again, it's as bogus as me saying the pattern inside this tube, because it looks just like Newton's rings, is Newton's rings. Alright, let's see. Sorry, I wrote these yesterday, so I was going to play the clips because they were just so bad. So I have some time codes here, but fuck it. So he says that prisms are real examples of, how can anybody not think that's a wave going through a prism? And again, it's all of these things are electrons and photons. That's quantum electrodynamics. That was the original discipline, was understanding how photons react and interact with electrons. So clearly the argument being made is that the surfaces are covered with electrons, that all material surfaces end up with electrons on their surface. It's inevitable. There's electrons in the environment, and if they're proton heavy on some side, that side's going to end up with a bunch of extra electrons on it, just because protons can never show their naked butts, so to speak, without an electron saying there's opportunity there. If you want to make it into a homo thing or something, but yeah, it really would be, the proton is a girl and the electron is a boy, kind of a thing, I suppose. Boys hate boys, but not in this world. Anyway, lots of men comforting each other. See, we gotta protect each other from them women's. They're coming to get us with all their rules about we can't rape them and stuff. It's pathetic. Alright. Let's see. So there was some key fact here. No. So anyway, so he kept doing, and obviously I could explain a prism. I can explain the surface phenomenons that take place with different materials in terms of diffracting light, just as you can explain rainbows based on the fact that that photons go into material substances that have free electrons, and the electrons move and they readmit the photon at new angles, and that's quantum electrodynamics. You don't need any wave for that to happen. Different frequency photons will move electrons different amounts of distance, and that difference in distance will end up to a difference in angular conversion. So again, I'll make a quick drawing. I mean, the idea would be, look, a photon hits an electron, and the electron's always in a position that's locked with other electrons. So if, say, a photon hits it straight on, well, then you can imagine the electron goes straight back, and then it goes straight back again and readmits the photon straight back. So if the photon comes in at an angle, it's going to hit the electron. The electron is going to tend to move towards this electron. Well, they don't like each other, so it's going to do this archy thing. Okay? And it's going to decelerate as it does that. Okay? And so it's probably going to emit a photon in the direction opposite of where it was, originally going. So it might, I'm doing bad geometry here, but I'm just saying the idea is that the end result is the electron is going to do some kind of U-turny thing, and it's going to end up decelerating at a new angle, and the new angle will be the angle of incidence, is the angle of reflection. So in a sense, the electron is going to be moved in where it can go, and it's going to decelerate, and as it starts to decelerate, it's going to release the photon when it goes back to its neutral position. So as it goes towards this neutral position, it's a position for which it's comfortable, the forces are balanced, it will release the imbalance it possesses, essentially. So it'll just give back the photon. So obviously this could be more angular. So I'm just giving you it could be that it moves in this direction, and then there's a reflection this way, and then it reflects this way. It could be a triangle. Could be lots of different geometry to how exactly the electron moves, because it's going to accelerate and decelerate at least twice through the process of readmitting a photon. And obviously that's what slows light down when it goes into surfaces, is that it's doing that reflecting thing, in the sense that it's accelerating and deaccelerating electrons, and that takes a little bit of time before the photon goes back on its course. Alright, so anyway, but that perfectly explains the process. And then so the more energy, let's say, or the less energy, is going to change the number of hits. The velocity, or the acceleration of the electron, and it's obviously going to change its angle where it's decelerating, and therefore separate colors out of random rays of light. And you can sort of also understand, I don't want to get into the steeper subject till maybe later. Yes, there'll be a later. See how long the guy in the camera is probably not going to last long enough for me to get to my later. Alright, so anyway, so he completely, in the video I had pointed out the fact that the math isn't matching the diagram, and just clear illustrations of how here's the two-slit pattern complex, here's the math simplex, and it's like he didn't even pay any attention. He just went back to, well, yeah, my graphic says all that, that piece of propaganda I put up, and he's not getting the point that no, that's not what's being described by the math. Nobody's doing the math for the actual product of the two-slit experiment. The actual product isn't being predicted. It isn't being formalized into an equation. The math doesn't produce the pattern. It doesn't model the reality. All right. So an equation is not code. Yes, so I don't need that. And then I don't know where he didn't. I don't know if he got to Huygens or not. But anyway. So, but it was like he wasn't even listening to the video, and he obviously doesn't know that I have. He obviously hasn't watched any of the previous videos to any degree, because he says things like the OpenCourseWare. I've played clips from MIT's OpenCourseWare, not only these laser videos, which Mr. Natural was nice enough to send me the link to, and I've watched about half of them, to tell you the truth. So I probably should watch the other half. They're very good. I mean, it's kind of boring guy, but he's very good. They're just demonstrations of I mean, I'd like to ask him to do some other stuff, but the stuff he does is good, and it creates lots of stuff where you say, shit, how do you explain that? Complicated. And then there's the actual lectures, which I've, 801, 802, 803, which I've watched all of. Hundreds of lectures. Literally. When you add it up. Hundreds. 100 and something, anyway. Because they have 803 and then 803X. They have two versions of 803. So anyway, but I've played clips of Professor Lewin. I've quoted him. I mean, it's like Piro doesn't even pay any attention to this, and clearly Hathaway doesn't, because he just keeps talking about how these are, what I'm referencing are some sort of like, well, this is just regular man science. This isn't like the serious science. The serious science they do right. And no, my whole point is I'm showing lectures where they're doing it wrong. Not Feynman lectures only, Yale lectures, MIT lectures. So this is just such a bullshit argument. And so it's obviously there's just no point in having any conversation with these people, because they will never admit the simple truth, which is the evidence isn't as good as it should be or needs to be for the level of arrogance and intolerance for speculations that exists in physics. They have zero tolerance for particle theory. They have zero tolerance for even having a conversation about whether or not there's a Heisenberg or a Huygens or even dark matter. I mean, they're so aggressively defensive of these contrivances. And this even goes back to the Einstein lensing thing. It is just established that this takes place. Now they've even just said they've seen gravitational waves, and it's, all of this is just, they're saying it, but they don't have evidence of it. Gravitational waves might be might be more legitimate than the lensing arguments. I don't think the gravitational waves depend on lensing, but they depend on black holes, which is also kind of a prove it kind of argument. Like, there's not a single black hole apparently within hundreds of they say the universe is 10 billion light years, well, 15 billion light years, right? 15 billion light years. I mean, it's just a preposterous number. And so there's nothing like within a billion light years of us. There's not a single black hole, because frankly that black hole should be lensing the entire picture of the universe behind it, and that there have simulations showing that. So there's not one single black hole in any kind of black area, where it actually has consumed all the matter in the vicinity, which it's supposed to be doing, that we can prove this lensing crap with. Not one. Anyway. Okay, so that's enough of that. I mean, not one of any spectacular size. I don't know what spectacular size would be anymore. Not big enough. Period. Okay, so enough of that. Sorry, I guess I didn't need to hold the camera through this video. Like we did a little tiny drawing, but it wasn't much of one. So, summing up. Alright, so I was thinking of just for somebody who's familiar with the different philosophical perspective. Okay, you have the ether people, so that's the electrical universe kind of people. So they're basically saying there's a structure in the universe, a force field, a field, let's call it, no force, a field, and the field allows energy to perpetrate through it. So, and it does this instantaneously, which is a little bit tricky. Parts of it, anyway, are somehow instantaneous, which, you know, there's no evidence of that. But anyway, I won't pigeonhole all the ether believers into what some ether believers say. But the general idea is that the ether would be like dominoes. The dominoes aren't moving, they flip. So things can perpetrate, which is basically the dominoes all flip and then they pop back up, let's say. But they do something to allow a signal to go through, and then the dominoes pop back up, this kind of thing. But there's no, the ether isn't active or grinding. Okay. Even though they do talk about pressure, they never make it real in the sense that they don't apply any structure that would imply this pressure, the creation of it, the movement that would create the creation of it. But anyway, that's the idea. There's this ether theory. Okay. On the other side, you have the bent space quantum mechanic thing. So that one's basically saying that the energy of the universe is all Heisenbergy, wavy little bits of blah blah blah. Who knows? That doesn't really know what it's doing, and somehow the space and the matter, well, the matter doesn't tell it what to do. Well, who knows? On the quantum level, there's no explanation. But anyway, so they put the force of gravity, you know, the energy that's pushing the Earth into the sun. It's obviously something energetic happening, in the sense that there needs to be something that's maintaining that force. It's not that the force itself uses up something, but in the activity there's clearly a use. So in the activity there has to be something expired. Something has to, you have to say, where did it go? The velocity of the Earth doesn't slow down, the Earth doesn't get lighter. Somewhere this force has to be accounted for, this energy. And bent space basically takes all of the energy of gravity and slides it into another dimension, this bent space-time place. Alright, and then there's my theory, okay, which simplifies the whole thing by saying, no, the quanta are the force, the light. Light is a force. It's a tiny bit of the force in the universe, visible light, but frankly it's a lot of what suns produce in terms of their energy, their force, as percentages of force anyway, but a tiny percentage that is visible, that, you know, that has this frequency thing, and the rest of these tons, like radio waves going through you right now, microwaves going through you right now, totally invisible, cosmic rays, all kinds of stuff going through you, little invisible photons that you'll never see or feel. The magnetism, you know, doesn't affect me, okay, but it clearly affects other things that are configured to be magnetic. I mean, this doesn't do anything for me, but does something for these scissors. You know, it's a force. That it takes a force to resist gravity here. This, you know, I mean, obviously the force is my hand holding it, but I just mean the force that makes this possible. This magnet has actually lost its magnetism somehow. You know, it's gotten really weak. Anyway, I must have banged it too much or something. I don't know. I thought they should have been kind of permanent unless you heat them up. Anyway, neodymium, it's ceramic. I shouldn't be able to bang its magnetism out of it. Anyway, it's a subject for another subject. Another video. Um, so yeah, so my explanation would be, look, you don't need bent space. Just make gravity an active force. Make the ether quanta. Randomize it, and you have what's called pressure. And now that you have pressure, now you can explain why the Earth is getting pushed into the Sun and the Sun being pushed into the Earth. And you can use that pressure and say, well, look, if I polarize that pressure, I can maybe create something like a magnet. You know, if the pressure has two colors, a blue and a green, or a blue and red, I can imagine that all the blue force is coming out of here and all the red force is coming out of here, and that now they've been segregated, these two forces, and the two forces will affect electrons in the opposite way in terms of which way they'll be attracted or repulsed. And so I can use this field energy, the invisible radio waves and microwaves and cosmic, all the ray stuff that I'm not seeing, plus the gravity rays, gravitons. I can use their energy not only to make this fall, because it has mass, but I can make this a filter of that energy. And that's how you get magnetism. And then going a step further, I can say, yes, electrons and protons have that ability to filter and become monopoles. And that they will create attractive and repulsive force, essentially. They will be attractive and repulsive because they will produce, they will emanate quanta that causes other things to accelerate, so they accelerate away, and the opposite effect, where they will create force that will be inert and therefore allow things to accelerate into them. They will change this pressure dynamic, and changing it, it means changing the mix of it, segregating out a color, and that will change the attractive, and that'll change how electrons and protons move. What kind of water? Say if I could call it a stream, and I made it a blue stream, well, the protons would swim upstream and the electrons would swim downstream. It's that kind of thing. So it's a filtering mechanism. Once you start segregating this force, that's neither an ether nor a bent space. It's an active elemental physics. This is the element. They're all moving the speed of light. So again, if I said instead of the speed of light, if the vernacular was the speed of force, because that's the truth here. I mean, it's a glaring truth that force moves at this speed, and light just happens to be one of the forces. Light is made of this force stuff, the same stuff that magnetism is made out of and gravity is made out of. And that some of this force you detect by watching it make things move, and some of this force you see with an eyeball. And those are the differences. But it's all those forces that create everything else. A sound wave is not a sound wave. It's not anything other than real physics, meaning real quanta, which means it's a wave of gravity, or it's a wave of magnetism. It's a wave of these tons that are that have changed the disposition of the matter and given it a thing called acceleration, and in the context of atoms, given it something called velocity or inertia, momentum, I mean. So but anyway, so that's sort of the broadest look at it. Is you have people who are obsessed with electricity and creating dead conductors, space, and people obsessed with multi-dimensional answers, making gravity into some other dimension, put everything in some other dimension, times another dimension. It's not something that's happening here. And again, the time dilation one is another one that's just so obviously full of huge paradoxes, where if you just simplify things and say all clocks are broken, okay, if they're moving, Okay, if they have velocity, they're broken, especially an atomic clock. And so that if you can find a neutral place in space, that's the clock that works. And if you just measure everything by that clock, you're fine. Or if you take any one of these frames they talk about, like I'm in a spaceship moving the speed of light, and somebody else is in a spaceship moving the speed of light. Well, if one of the rules was that anything we do, we have to leave a piece of our matter behind. That is, we have to eject something, okay, that isn't moving the speed of light, that doesn't have our momentum, that goes back to a neutral momentum. Well, if we all had that obligation to deposit something that wasn't moving, whatever velocity we have, then we'd all see, because then we would notice how fast we left the piece that's not moving, and everybody would be able to see how the different frames are moving. So I'm just saying it's just a reference problem. It's not a, there's no physical reality that there's anything like I'm moving the speed of light and I'll shine a flashlight across the room. That can't happen. I turn on the flashlight, if I could turn a flashlight on, if I could move matter the speed of light, I turn the flashlight on. Well, I left that beam of light. It's receding as I'm moving away. It's doing its thing. It's moving a straight line, the speed of light. It isn't carrying my momentum with me. So I can't shoot light across the spaceship in a spaceship over the speed of light. I can't do it physically. Everything in the ship is moving away. The light is doing its thing, its constant thing. And it can't do two movements at the same time. It can't move the speed of light this way and the speed of light that way at the same time. That's not what forces do. And that's just obvious. And it's just nonsensical to say, with this theory of relativity, I'm going to break that rule. That's, in my opinion, just crazy. It's so bad. it's such a flaw in the theory. Alright, so time's not a dimension, it's just a function. And you see the function differently, but the function doesn't change. It's only a perception, it's not a reality, if to say it some way. And it's not even a perception if you did the reality. But you can't do the reality. You can't move matter the speed of light. It never happened. It turns into light. You got to follow these simple rules of dimensionality. I mean, I've tried to explain this, but light force is energy in one dimension. It's mass in one dimension. Photons don't have mass except in the dimension they're moving, and they have a mass of 1, or whatever you want to call it, the smallest mass in the universe, but it's the mass. They have a mass of 1 in the direction they're moving. And matter is basically photons moving in all directions. So I have mass in all directions because I have energy moving in all those directions at any 1 second of time. Okay. And the thing that makes me is just the fact that there's energy flowing, the water's flowing through me all the time, all the forces, just like the cosmic rays and the radio waves, they're all flying through me. But what they're flying through is a collection of polarization. And as long as they don't disturb that polarization, then I retain a balance in the fact that I end up having force in all directions. But if they do start to push me, then I start to lose my dimensionality in the other 2 dimensions, and I become the dimension I'm moving in. I become a force in the dimension I'm moving. But the only thing I really am is polarization. I'm not, my matter doesn't really move. The pattern that is me moves. So the pattern is pushed. You know, the pattern is merely replaced into a new place. I think of a way to describe that. But stuff is always going in and out constantly. The same amount of stuff is always going in and out of me. The only thing that changes is whether that stuff says the pattern has to be moved over here because there's more stuff changing the pattern over here. So my pattern bleeds into a direction. I'm going to find a better way to describe that. Alright, so the other point I have made previously as a criticism of the bent space thing is the idea that they liked the idea of this pull thing. They wanted a pull force. They wanted to figure out how the moon's being pulled into the earth. So again, you can almost go back to the flaws of the first perceptions of the universe, you know, where the earth was the center of the universe and the sun revolved around the earth, and all of those misperceptions. And this is just another one of those where they wanted it to be this attractive force rather than a pushing force. It was easier to imagine that way. I don't know exactly why. But push is obviously the easy force. Pushing, you can't get simpler than push. Pull is incredibly complex, and this is a huge flaw in the bent space analogy, is the idea that it creates this pull energy out of a non-existent dimension where you don't have to account for any of the energy. So you can make the well as deep as you want. You don't have to use anything called real force to create it. There doesn't have to be any real quanta that made it. So they can create imaginary wells that aren't limited by any kind of volume equations. Like how thick is the universe? How much quanta is there? How much can you collect in one little tiny place? Those kind of arguments are real arguments, and they get ignored, you know, because they've created a pull thing, a vacuum cleaner, and the vacuum cleaner has no exhaust. And that's essentially the metaphor for gravity. It can just suck in bent space. You can just bend the space for free. No energy required, just mass. Alright, yeah. So that's just a key, you know, just these are the key mistakes. Push versus pull, key mistake. Wave versus particle, but I mean, it doesn't even have to be particles. You just have to recognize that they're corpuscles, as Feynman would say. They're clumps. They're discrete and contained bits moving the speed of light with mass in the direction of their momentum, their velocity. And that's what they are. That's what energy is made out of, is the transferring of those bits. And the real key is the transferring of the conversion of polarization, taking something blue moving this way and making it move that way. That's the whole universe is made out of that right turn. Without that right turn, there's no color. there's no movement in the universe. That's what makes it all happen. Okay. So, but this idea of a wave doesn't have any. First, is intangible physically. Doesn't have any boundaries proper. It's not a definable blob. I mean, if they called it a blob and they just meant that it's this thing that moves around or something, or spread. See, it doesn't have any, light doesn't spread. It doesn't do all these things that they saying it does. And the powers they're giving it are just not, so I've made this simple argument before too. Here you have something really complex, matter, say in the two-slit experiment. Trillions of atoms. There's many, you know, the atom is to the apple what the apple is to the earth. Okay, I mean, trillions of atomic, magnetically held together constructs of protons and electrons. Trillions of complexly arranged magnetic objects. And here you have this photon thing. And instead of thinking, I think quite logically, that matter might make this little tiny thing do something, they're saying the little tiny thing is doing all the special stuff. It has all the information. Okay, the non-information of non-locality, non-momentum, non-inertia, non-structure, it's not obeying any material rules. And I'm just saying, I think it's kind of, again, you can't just, you need extraordinary evidence to discount the plain logic of saying the more complex thing is likely influencing the more simple thing, not the other way around. You know, space isn't telling matter what to do. Force is. You know, damn. Alright, so again, the key words here are just polarization. Matter might be a compression also of quanta, but it doesn't really matter to me. The polarization is the key thing. The blue being in the electron, the red being in the proton, the field energy being the reciprocal of that, a mixture of the red and the blue. And, you know, for every bit of blue you compress in matter, you got to take some out of the environment, kind of a thing. So that would be the compression argument, I suppose. But that's all there is. And there's just the fact that a blue thing reacts different to red quanta than it reacts to blue quanta. And a red thing reacts different to red than blue. So that's all you need to create a complex universe. And there's a simple rule of quantum electrodynamics, which is the simple rule is when electrons accelerate, they produce these blue or red things perpendicularly, EMF, electromagnetic radiation. And when they decelerate or lose their acceleration, they produce force ahead of them in the direction they were moving. And that's the whole entire Maxwell equations summed up. That's the entire function of electricity and magnetism and their connection to each other. The magnetism accelerates electrons, the electrons decelerate, creating electric force in the wire that moves more electrons that create more EMF, do more decelerating, create more electrons moving, blah blah blah. The photons moving forward through the conductor keep pushing the electrons, and as they push them, they emit the EMF, and it's as long as you have somewhere to push the electron, it will keep producing the acceleration and deceleration that will keep spreading the force. And it's really not, it all fits, it all works. It's a much more logical explanation than either a dead ether that doesn't, you know, coaxial cables or ropes or strings or nonsense, or some idiotic bent space, warped time, Heisenberg-Huygens perversion of reality. So that's the basics of the argument, and I'm going to argue that the people I'm arguing with are completely unfair to the strength of this argument and the weakness of the established premise experiments as evidence or proof of their theories of reality. Okay, so till next time, and the such.